Hey, what's going on guys? Tanmaya for Simple Snippets, back with another video tutorial on digital electronics, Boolean algebra and logic gates. So in this video tutorial, we'll be covering the topic of hexadecimal to binary encoder. Now in the previous couple of video tutorials, we've already discussed what a binary encoder is, and we've also seen a couple of types of binary encoder or encoders, that is parity encoder, decimal to BCD encoder, octal to binary encoder, and so on. So if you have missed those videos, you can check those videos in this playlist, and I'll drop a link to this entire playlist of digital electronics and Boolean algebra in the description. And you can also see a card on the top right corner, so you can see all the topics covered in this entire subject. Also, if you are new on this channel, make sure you subscribe to this channel because you'll get notified whenever I upload a video tutorial like this one and many other video tutorials related to information technology and computer science oriented subjects. So now that you've subscribed to this channel, let's get started with today's topic. So in today's topic, we are going to be understanding how hexadecimal numbers are converted to binary numbers using an encoder device. So as the name suggests, hexadecimal to binary encoder converts a hexadecimal number to a binary number. Now if you don't know what hexadecimal number is, then you can check out this video on the top right corner in terms of link, and I have already covered different types of number systems and the conversions between the two in a separate playlist altogether, so you can just have a look at the different number systems. Basically, hexadecimal number system is a number system which has a base of 16, which means that it has 16 different symbols. You can see the input over here. So these are the 16 different symbols of a hexadecimal number starting from 0 to F. So for the first 10 digits, that is 0 through 9, it resembles exactly equal to decimal number systems for 0 to 9 in decimal, but a 10 in decimal is represented as a A in hexadecimal. So 11 is B, 12 is C, and so on till 15, which is F in hexadecimal. So that's the only difference between hexadecimal and decimal. And then the binary representation is going to be the same. So for 0 we have 4 times 0, for 1 we have 0001, which is totally on the positional weights. Okay, so for A, that is 10 in decimal, we have 1010, for 11 we have 1011, and till F we have 4 times 1. So this is the input that the hexadecimal to binary encoder is going to take. So it is going to take 16 line input, and the output is going to be a 4 line output, which is going to have 4 output lines, which is starting from B0 to B3. So let's draw the box diagram first. Okay, so as you can see on the screen, I have drawn the box diagram for a hexadecimal to binary encoder. You can see the input lines which are in orange to the LHS. So these are the input lines D0 through DF. So I've just named each of the line with a D and then the numbers, that is D0, and you can see till D15 or DF is the number for hexadecimal. And then we have the output lines, which are four output lines starting from B0 to B3. So now what we're going to do is we're going to construct the entire hexadecimal to binary encoder circuit. So obviously there must be some circuit inside this box which converts the hexadecimal number to a binary number. So for example, what happens is at a single time, only one of these 16 lines is going to be high, right? That's the encoder functionality. So if D0 is 1, all the other lines are going to be 0, and then it is the encoder's responsibility to take this input, that is to take all the 16 inputs on and keeping only D0 high, and then giving the corresponding output of 4 times 0. Similarly, if D1 is high, that is the second line is 1, all the other lines are going to be 0, and then the output is going to be B0 is going to be 1, you can see over here, and rest are going to be 0 0 0. So this functionality has to be implemented using some logic gates inside the entire encoder circuit, right? So we are going to find out what exactly is being used inside this hexadecimal to binary encoder and the circuit diagram. So in order to do that, we need the output expressions for the 4 output lines. Now each of these input line D0, D1, D2 represents one hexadecimal number. So D0 represents 0 and DF represents the F. So in between you can like easily figure out the different allocations, right? So at a time only one of the line is going to be high and it corresponds to one hexadecimal number. Okay, so let's first get the output expression for each of these output lines. So let me just write it down, B0. So what we're going to do is we're going to find out all the inputs where B0 is going to be high. So this is one such case, right? So for that we have D1. So I'll write D1. Then let's find out the next case. So you can see over here, this is D3. So take a OR operation and write down D3. Then one more OR, and for this we have D5. Then we have D7. Then we have D9. Then we have D11. Then we have D13, and lastly we have D15. Okay, so all of these values when come in as input, the B0 output is always high. So that's why this entire expression. Now let's find out for B1. So for B1, you can see we are comparing this column now. So we have D2 and D3, then we have D6 and D7, then we have D10 and D11, and lastly we have D14 and D15. Okay, so you get the idea, right? We just have to take all the values where the output is 1, and for that corresponding we just have to write down the input with an OR operation. Okay, so I'm just gonna mark for B2 and B3 quickly, and probably you can just note this on a piece of paper or a rough book. So for B2 we have these 4 values, and these 4 values I'll just quickly write them down. Okay, so I have written all the output expressions for each of the outputs. Now we can easily construct the circuit diagram. So let's start off with constructing circuit diagrams. We need to first have 16 input lines. So let me just draw those lines. Okay, so I've drawn the 16 circuit lines, you can see, and it looks a little big and complicated, but it's going to be very easy. So let's start off with the first one, that is B0. So for B0 we have D1, D3, D5, D7, D9, D11, D13 and D15. So just mark those lines. So first we have D1. So this is that line. So draw out a circuit line from over here. Okay, so then we have D3. So 0, 1, 2, 3. So this is that line. Then we have D5. Then we have D7. We have D9. We have D11. We have D13. And we have D15. So all of these lines go to a one big OR operation, and then these are passed to an OR gate. So let me just draw that OR gate, which gives us the output of B0. So this is OR gate 1, and you get this exact output because there is an OR operation in between all of these circuit lines and input lines. So passing all these lines exactly into the OR gate, we get that output. So this is pretty much it that we have to do for B1, B2 and B3. So I'm just gonna quickly draw these lines and then you'll get the idea, right? Even you can do it along with me. So I'm not going to waste a lot of time showing you how to do it. You can easily pick out D2, D3, D6, D7 for the B1 line, for B2 line and for B3 line, and draw 4 more OR gates. So let's see how that goes. Okay, so this is the complete circuit diagram of hexadecimal to binary encoder. You can see there are a lot of circuit lines, but then it is very easy. We just have to connect the respective circuit lines for the corresponding output, and you can pause this video and you can just draw it out yourself. And yeah, this is basically what exactly is inside this box. So this entire circuit is what exactly inside this box, and this is how you get the hexadecimal number to be converted to a binary number. So yeah, that's it for this video guys. I hope you understood hexadecimal to binary encoder conversion and what it does and how it looks like in the circuit diagram and also the truth table. So if you like this video, give it a thumbs up, share it with your friends, and make sure you subscribe to this channel because you'll get notified whenever I upload a new video tutorial. Peace.